In this video we shall continue discussing normal forms. Just a quick reminder that these normal forms we've already discussed in the previous video. Now we shall discuss these normal forms, and these we shall discuss in the next and the final video. Let's begin with the third normal form. A real var is in the third normal form if it satisfies the second normal form and has no prime attribute that is transitively dependent on the primary key. How does it look like? We've already seen this relation described in some student group, but here we have additional fields about the faculty, the dean of that faculty, and the date of birth of that dean of that faculty. It's absolutely obvious that this primary key is describing any group, so the faculty depends on the group and the dean of the faculty depends on the faculty, and this field also depends on this field because this is one entity. So this is the transition between primary key and some field and some other fields. And so that's the violation of the third normal form. So how can we deal with this violation? We shall split the initial relation into several ones, like group, faculty, and staff. And we may see that no transitive dependencies are here, because that information about faculty dean is not here. And the information about the faculty dean, date of birth, name is not here. The information about that person is here, and the information about the faculty and its dean is here. So no transitive dependencies, neither here, nor here, nor here. And that's how we can deal with the violation of the third normal form. Here is a short conclusion. The third normal form doesn't protect you from local mistakes. For instance, imagine that some group should be at the third faculty, but we somehow place it to the fifth faculty, for instance. We can make such mistake, but we cannot violate some global rules like who is the dean of what faculty, what is the date of birth of the dean, and so on. Those rules are always preserved. And one of the most obvious evidence of the third normal form violation is that a relation has some attributes with multiple values duplication for many tuples. Such attributes are the first candidates to moving to another relation. Imagine such a situation when we have a relation, that initial group relation, and we have here information about faculty, about the dean of that faculty, about the date of birth of that dean, about some other information about the dean, like, for instance, the room he is sitting in, and so on and so on and so on. And we have something about, let's imagine, 150 groups on a faculty. So all that information about faculty, dean, and so on and so on and so on will be duplicated 150 times. So that's the idea of the duplication. Once we see such a duplication, we may know that there is a violation of the third normal form. So we have to split that initial relation into several ones and deal with the violation. The Boy's code normal form tells us that a real var is in that Boy's code normal form if it satisfies second normal form and has no attribute that is transitively dependent on the primary key. And let's compare to the third normal form. With third normal form definition, we see that non-prime word, and we do not see that non-prime word here. So this is the main difference. The third normal form talks only about non-prime attributes, and the Boy's code normal form talks about each and every attribute, no matter if it's prime or non-prime. Let's see how it looks like. Imagine such a relation describing some gifts, and there are subject matter rules. The first rule: no set may contain two or more items of the same type. We see three sets here. This is the set 1, the set 2, the set 3. And we see no duplications among types of items in each set. The second rule: no set may contain two or more items of the same name. Once again, no duplications among names within set. And the third rule: no item type may contain 2 or more items. We see that toys are only teddy bear, sweets are only marmalade, fruits are only oranges, and the same values here. So all rules are satisfied. But we may see that this attribute GName is dependent on GType due to the third rule, while GType itself is not a candidate key, because this field allows duplications. This is not a key attribute. So this is the violation of Boy's code normal form. How can we deal with this? We may split that initial relation into two new relations like set and object, and describe object types and names here, and then here we describe sets and assign some object types here. So no violation here and no dependency of any attribute like here from here. Here it exists. Here no such dependencies. So no violation of Boy's code normal form. The short conclusion. Boy's code normal form, like the third normal form, doesn't protect you from local mistakes. For instance, maybe in some set there should be fruits, but we put some electronics there or something like that. Such mistakes may exist, but we cannot violate some global rules, like name for each fruit, name for each electronics, name for each something like that. And that's good. The next idea. One of the most obvious evidence of Boy's code normal form violation is that a relation has candidate key intersection. For instance, we have some relation with three attributes, A, B, C, and we see that there are two candidate keys in such a relation. The first candidate key is AB, and the next is BC. And we see there is an intersection with the field B. So that situation is a sign of Boy's code normal form violation. And we have to emphasize that most relations that satisfy the third normal form also satisfy Boy's code normal form, because Boy's code normal form violation require specific subject matter rules, and those specific subject matter rules are extremely rare. You may almost never see them in real life. So once you have the third normal form, it's almost sure that you have Boy's code normal form, but you should absolutely check. The fourth normal form says that Error is in the fourth normal form if it satisfies Boy's code normal form, and any multi-valued dependency that holds in this relation is implied by some superkey. I know that this doesn't look simple, so we shall now see an example. I hope you remember this relation from one of our previous videos when we were discussing dependencies. So some university application. One applicant may apply to several faculties, and in each faculty there are several exams. So once Sidorov is applying to physics faculty and there are computer science and physics exams on that faculty, we have to add that another record. So this is the violation. We want to add one record, but we have to add another. One, another, two, other, three, and so on and so on and so on, depending on the subject matter rules. That's the violation. We may deal with that violation several ways. The first one is so-called scientific. This is before, this is after. You see that there is one and two new relations with no relationships here. It's clear we cannot add some foreign key here without getting the initial relation. So this is rather good, but not so good enough. The good technical approach looks like this. We have 5 new relations about applicants, where each applicant is mentioned one time only, about some faculties, and once again each faculty is mentioned one time only, and about exams, when each exam is mentioned one time only. And we have interconnections about applicants and faculties and exams. So this is how we may deal with violations of the fourth normal form the engineering way. And the short conclusion here. The fourth normal form, like Boy's Code normal form, doesn't protect you from some local mistakes. For instance, some applicant wanted to join one faculty, but you somehow assigned him to another faculty. That's local mistakes and we may still make them. But we cannot violate global rules, like what exams are on what faculties, and so on and so on. One of the most obvious evidence of the fourth normal form violation is that a relation has a group of 3 or more attributes with pairwise dependencies inside such group. So we have to have at least 3 attributes like A, B, C, and we see some pairwise relations between A and B without C, or between B and C without A, or maybe between A and C without B. Once we see that pairwise dependencies, that may be a violation of the fourth normal form. Of course, such subject matter rules that lead to violation of the fourth normal form are rare. So we may remember that most relations that are in third normal form are in Boy's Code normal form, and most relations that are in Boy's Code normal form are also in the fourth normal form. So most relations that are in the third normal form are also in the fourth normal form. Not all of them, but the majority of them for sure. And we shall finish normal forms discussion in the next video.